Okay, so in this lesson we're going to look at the application of Gauss's law. And Gauss's law is extremely powerful in situations where you have symmetry, and it makes calculation of the electric field very quick and very easy. So we're going to suppose that we have a uniformly charged sphere of radius r, and it's got a total charge of q. Okay, so let's just draw the sphere up. Okay, so radius r, it's a positive charge, and it carries a total charge of q. Okay, so the first thing that we do is we draw a surface, which is called a Gaussian surface, around the outside of our charged sphere. And this Gaussian surface has got a radius which is given by a little r. The next thing we do is we're going to write up what Gauss's law is. So we have the surface integral of E dot dA is equal to the total charge divided by epsilon naught. Okay, now in this situation, what we have is for our infinitesimal surface area element, dA, r is constant, but phi and theta are changing. So we have dA is equal to r squared sine theta d theta and d phi, and it's in the r hat direction. You see that the electric field, since we have a sphere, is also going to be in the r hat direction. Okay, so our dot product is going to cancel out, and what we now obtain is the integral of the magnitude of our electric field over the surface is equal to the total charge enclosed, which is q over epsilon naught. So we integrate d theta between 0 and pi, and phi between 0 and 2 pi, we're going to get to 2 pi. And also, since the electric field, the magnitude of the electric field is going to be constant over the surface, we can bring it outside the integral. So now we have our electric field by the integral of dA, which is between 0 and 2 pi for phi, and 0 and pi, of r squared sine theta d theta d phi, and this is equal to q over epsilon naught. Okay, so when we do this integral, we're going to get 4 pi. So we've got 4 pi so what results is the magnitude of E times 4 pi r squared is going to be equal to q over epsilon naught. Or alternatively, what we can write is our electric field E is equal to 1 over 4 pi epsilon naught by q all over r squared. It's in the r hat direction. Okay, so what we find quite nicely is that the electric field is just like that as for a point charge. It's as if all the charge is located at the center of our sphere. Okay, and the electric field, as we can see, is going to fall off as 1 over r squared the further you move away from our sphere.